Hi, welcome back. In this video, we're going to talk about how to solve a cubic equation. Now, in our previous videos, we talked about how to solve polynomials and quadratics specifically, but here we're going to talk about a cubic polynomial. And they will look like this. The general form of a cubic polynomial, the highest exponent is x cubed, right? Which means we would have a coefficient with it, possibly an x squared, an x, and a d. So we're going to be solving a cubic polynomial where the highest degree is a 3, right? And for cubic, we will have several methods to use. We're going to focus specifically on the grouping method for factoring. If you want to look at a video that I made on our previous unit, I have a video specifically factoring cubic polynomials using the grouping method. So if the examples that I showed you today are not sufficient to help you recap or to help you factor and solve, feel free to go back to my other video so that you can watch how to factor a cubic equation. All right, let's get to it. So here's a scenario, right? Before I begin any problem, my cubic polynomial, all the terms are on one side of the equal sign. Everything's on one side. And it's in descending order from the highest power to the lowest power. What I want to do as well, before I begin any problem, is I want to start with making sure, can I simplify this polynomial to something smaller? Are they all divisible by a number? And as you can see, they're all divisible by 2. So I'm going to do that. I'm going to simplify the equation by dividing everything by 2 so that I can work with smaller numbers versus bigger numbers. The problem will work the same either way, but this will simplify the process a little bit. And that leaves me with x cubed minus 8x squared, because I'm dividing it by 2, minus 2x plus 16 equals 0. Now, I did mention in a previous video that we can do PEMDAS backwards whenever we're trying to isolate the variable. Right? I did several examples on the square root method where I show you how to isolate a variable when there's only one variable. So, if we had one variable, I can isolate it using SADMET. But here I have a lot of them. So I'm going to have to get creative with how I separate these variables. And we're going to do that today by factoring. Now, factoring a cubic is a little different than factoring a quadratic, right? So I'm going to do this by separating this into 2 groups. The group on the left and the group on the right. So what I do is I look at the group on the left, this half of the problem. What do these 2 share in common? Well, they both have an x in common. And actually, they both have an x squared in common. That is the greatest common factor. That is the highest term that they both share together. And what I want to do is I want to divide both by x squared. When I do that, x cubed divided by x squared leaves me with just x. And negative 8x squared divided by x squared leaves me with negative 8. Meanwhile, on the other side, right, on this right side of the problem, I have 2 terms. What do these 2 share in common? Well, they both share a 2 in common. So I'm going to factor out a 2. What do we notice though here? That when I divide by 2, I'm going to be left with a negative x. And I actually want to have the same value here. I want them to match. So I'm going to strategically divide it by a negative 2. Because negative divided by a negative gives me a positive x. And 16 divided by negative 2 gives me a negative 8. And as you can see, I have 2 terms here that I want them to match. Again, there's a lot more examples that I do on a previous video, and where I explain this more in detail. Now, up here, or in this scenario, right, in this step, we didn't have anything in common that we can do. But now that I've broken this into 2 groups, notice how the 2 groups share x minus 8 in common. So that will be my factor that I'm going to be working with. So if I divide both terms by x minus 8, what am I left with? X squared minus 2. I have found my two factors that create a cubic function. If I wanted to do FOIL, first, outer, inner, if I do FOIL and all of that, I will get back to the beginning, right? And this is still an equation. This equation still equals 0, which means we still want to solve for x. But now that I've separated into two factors, I have separated all of these four terms into two products, into two factors. And I can set them each equal to 0. Here I have a linear polynomial, and I just have to solve for x. So I move a to the other side. This isolates the variable. Here I have a quadratic. We did talk about three methods for solving a quadratic, right? The last three videos. We spoke about factoring. We spoke about the square root method, which is just PEMDAS backwards. And we spoke about our third method, which is the quadratic formula. To solve these, if I wanted to use these other methods, I would want to make sure that here, since I'm missing an x term in the middle, that I could change the equation to x squared plus 0x minus 2. I can add the middle term if I want to find a, b, and c. Whether I want to use the quadratic formula or whether I want to break this into columns and factor it. But I'm going to focus on this method because there's only one variable and I can isolate it. I do PEMDAS backwards, right? Start with addition and subtraction. Move the 2 over. X squared equals 2. And now, how do I get rid of the exponent? Square root both sides. That leaves me with x equals plus or minus the square root of 2. I have my three solutions. 8, positive radical 2, and negative radical 2. And I have three solutions because I'm dealing with a cubic polynomial, right? Which means the polynomial will have at most 3 x-intercepts. Something like this, right? Our cubic polynomial can look something like this, where there are 3 x-intercepts. Maximum 3 x-intercepts. It could have less. It could look something like this, where it crosses twice, or maybe it just crosses it once. But a cubic polynomial will never have more than 3 solutions. It can only cross 3 times at most. And here we can see that with our example. All right, let's do another example. Again, if you're struggling with this process after we do a few examples together, remember I have an entire video dedicated to factoring cubic polynomials. And you can watch a video where I use grouping as a method to factor polynomials for more details. All right, let's do this one. When I see this problem, I want to make sure first that it's written in standard form where all the variables are on the left, or all of the variables are on the same side as my highest degree. The highest power here is x to the third power, and the coefficient is positive. So since it's positive, I want to move everything to the left. So I subtract 16x on both sides. I subtract 48 on both sides. And that results with x cubed plus 3x squared minus 16x minus 48. And I'll just make it equal to 0 over here. Here's my problem, right? This is what I'm going to start with. Remember, your polynomial, whenever you move things to the left or to the right, whichever side you prefer, whenever you move it, we're aiming for everything to be on the same side of the equation, and this coefficient of the highest power, we're aiming for that to be positive. So you're going to want to move it to where it's positive. And since it was positive, I moved everything to the left. Now the next thing that I do is, can I simplify this problem by dividing all the coefficients by a common factor? They don't. They're not all divisible by 2 or by 3, like in our previous scenario, right? So this is what I'm going to work with. I'm going to split this into 2 groups. On the left, they both have an x squared in common. So if I factor out an x squared by dividing both terms by x squared, I'm left with x cubed divided by x squared is an x, and 3x squared divided by x squared leaves me with positive 3. I notice that these are all positive and these are all negative. So when I factor this out, I want to divide it by a negative number. Because negative divided by a negative is going to be a positive. So I'm going to divide it by the greatest common factor. And the greatest common factor of these two terms is 16. Or negative 16. So if I divide this one by negative 16 and this one by negative 16, I'm left with positive x and positive 3. You see how these two match? That's what we're going for. Now let's say that you didn't know that it had to be 16, and all you realized was like, well, they're both even numbers. Can I divide them by 2 or divide them by 4? If I want to divide this by something else, and let's say just take out a 2. If I divide it by 2, we would get negative 8x minus 24. Would this have matched the left side? No. And that's my clue, right? When this parentheses does not match this one, I know that I need to divide by something greater. So when we go all the way to 16, now these two terms match. And that's what I'm aiming for. I'm aiming for these two groups to have common factors. All right, back to the problem. So I divide both by the common term, x plus 3. I'm left with x squared minus 16. And again, these are all equal to 0. So when I'm solving, I want to get what is the value of x. Yeah, I set each factor equal to 0 because now we've been able to separate these. We weren't able to separate the x's here, but through factoring, through grouping, I am able to separate the two factors. So now I can separate them further. X plus 3 equals 0, and x squared minus 16 equals 0. I just said further instead of further. So let's solve for x. Subtract 3, x equals negative 3. To isolate the quadratic, again, you can add a 0x term if you prefer the factoring method, or if you want to do quadratic formula, you just need a, b, and c if you want to do quadratic formula. I'm going to do PEMDAS backwards, where I add 16 on both sides. And now to leave to get rid of the square, I square root it. I just got to remember that this problem is a quadratic, and when I square root it, I only have 1x. So I need to account for the fact that the original problem had two sides, a positive and a negative side. So anytime I change the problem, I need to account for that in the solution. I can't just go from x squared to x. I can't go from two possible answers to one answer. I need to make up for that when I square root it by making it a plus and a minus. And here are my two solutions. Or three solutions, positive 4, negative 4, and negative 3. And we do that whenever we have a cubic polynomial or a cubic equation with my 4 terms. I hope this has helped. Please let me know if you would like some more examples or if you have any questions. If you have questions about how to do more of these scenarios, first watch the video, and my previous unit is in a different color. And don't forget to like and subscribe. And as always, I'll calculate.